Machine Learning for Absolute Beginners, written by Oliver Theobald. Chapter 1. Machines have come a long way since the onset of the Industrial Revolution. They continue to fill factory floors and manufacturing plants, but their capabilities extend beyond manual activities to cognitive tasks that, until recently, only humans were capable of performing. Judging song contests, driving automobiles, and detecting fraudulent transactions are three examples of the complex tasks machines are now capable of simulating. But these remarkable feats trigger fear among some observers. Part of their fear nestles on the neck of survivalist insecurities and provokes the deep-seated question of what if? What if intelligent machines turn on us in a struggle of the fittest? What if intelligent machines produce offspring with capabilities that humans never intended to impart to machines? What if the legend of the singularity is true? The other notable fear is the threat to job security. And if you're a taxi driver or an accountant, there's a valid reason to be worried. According to joint research from the Office for National Statistics and Deloitte UK published by the BBC in 2015, job professions including bar worker, 77%, waiter, 90%, chartered accountant, 95%, receptionist, 96%, and taxi driver, 57%, have a high chance of being automated by the year 2035. Nevertheless, research on planned job automation and crystal ball gazing concerning the future evolution of machines and artificial intelligence, AI, should be read with a pinch of skepticism. In his book Superintelligence, Paths, Dangers, Strategies, author Nick Bostrom discusses the continuous redeployment of AI goals and how 2 decades is a sweet spot, near enough to be attention-grabbing and relevant, yet far enough to make it possible that a string of breakthroughs might by then have occurred. While AI is moving fast, broad adoption remains an uncharted path fraught with known and unforeseen challenges. Delays and other obstacles are inevitable. Nor is machine learning a simple case of flicking a switch and asking the machine to predict the outcome of the Super Bowl and serve you a delicious martini. Far from a typical out-of-the-box analytics solution, machine learning relies on statistical algorithms managed and overseen by skilled individuals called data scientists and machine learning engineers. This is one labor market where job opportunities are destined to grow, but where supply is struggling to meet demand. In fact, the current shortage of professionals with the necessary expertise and training is one of the primary obstacles delaying AI's progress. According to Charles Green, the director of thought leadership at Bellatrix Software, it's a huge challenge to find data scientists, people with machine learning experience, or people with the skills to analyze and use the data, as well as those who can create the algorithms required for machine learning. Secondly, while the technology is still emerging, there are many ongoing developments. It's clear that AI is a long way from how we might imagine it. Perhaps your own path to working in the field of machine learning starts here, or maybe a baseline understanding is sufficient to fulfill your curiosity for now. This book focuses on the high-level fundamentals, including key terms, general workflow, and the statistical underpinnings of basic algorithms to set you on your path. To design and code intelligent machines, you'll first need to develop a strong grasp of classical statistics. Algorithms derived from classical statistics sit at the core of machine learning and constitute the metaphorical neurons and nerves that power artificial cognitive abilities. Coding is the other indispensable part of machine learning, which includes managing and manipulating large amounts of data. Unlike building a Web 2.0 landing page with click and drag tools like Wix and WordPress, machine learning requires Python, C++, R, or another programming language. If you haven't learned a relevant programming language, you will need to if you wish to make further progress in this field. But for the purpose of this compact starters course, the following chapters can be completed without any programming experience. While this book serves as an introductory course to machine learning, please note that it does not constitute an absolute beginner's introduction to mathematics, computer programming, and statistics. A cursory knowledge of these fields or convenient access to an internet connection may be required to aid understanding in later chapters. For those who wish to dive into the coding aspect of machine learning, Chapter 17 and Chapter 18 walk you through the entire process of setting up a machine learning model using Python.